Going on, everybody? Starting a new chapter today, chapter 9. Chapter 9 is on circles. And today specifically, lesson 9.1, it's just an intro to circles. It's mostly vocab, and then are also going to be talking about angles within circles. Okay. Just like always, the notes and these slides are available in Canvas, so please go in there. Use the notes that are there in Canvas to take down your own notes. Or create your own, and always use the PowerPoint slides that are in there to help you with your notes and or homework and things like that. Okay, our objective is to learn the properties of circles and arcs. Okay, a circle is a curved line that is always the same distance from a given point, right? So that means the point is going to be what we call the center, and every part of this circle is going to be the same exact distance from that center, right? And a circle will always measure 360 degrees. Okay, so vocab, center is the point from where all lines of a circle are the same distance, right? With my extremely terrible handwriting, if there's a circle and there's a center, any line that you draw from this center to the outside of the circle will be the same exact distance. If this was an actual true circle, it doesn't matter what line you draw. If it touches the center and if it touches the edge, it is the exact same distance. Okay, a chord is a segment whose endpoints are on a circle and do not pass through the center. A diameter is a chord that does pass through the center, right? So chord, right, the endpoints are on the edge of a circle somewhere, right? So again, with a crappy circle, right, the endpoints of any chord are somewhere on the circle. I'm going to draw all these afterwards, right? A diameter just has to go through the center. A radius is a segment whose endpoints are the center and some point on the outside edge of the circle. Okay, so we have a circle here. I'm going to draw all of those examples, right? Center is obviously there in the center, right? It's just a point. The center is always a point. A chord is a line that passes anywhere through the circle and has endpoints on the edges, right? So that would be a chord, right? It's just a line that goes through the circle. A diameter has to have endpoints on the edges, but a diameter has to go through the center, right? So that is the difference between a chord and a diameter, right? There is a picture of a circle on your notes, so I would recommend drawing all of these things as well. Okay, and then you also have radius, which is just endpoints is the center and somewhere on the edge. So that would be a radius. And then let me double check, see if there are any more. Center, chord, diameter, radius, right? We got all those. Center, chord. Chord does not have to go through the center, can go anywhere. Diameter has to go through the center, has to go touch both sides of the circle. And a radius has to have endpoints as the center and on the edge. Okay, some more vocab, right? Couldn't fit it all in one slide. A tangent is a line that intersects the circle in only one point. So you notice the word tangent. That was from last chapter, right? In this way, it means something different, right? It means that where it touches the circle at only one place. And the point of tangency is that place where the tangent line intersects the circle. Okay, a common tangent is a line that is tangent to more than one circle. And a secant is a line that goes through two places in a circle but keeps going. So you can think of a secant like a chord, except it has arrows and it keeps going rather than stopping. Okay, and once again, we have more circles to draw those things: tangent, point of tangency, common tangent, and secant, right? So a tangent line is somewhere that touches the circle in just one place. So that means it's going to go through the outside, just touch the circle, and then keep going and not intersect through the circle, right? So that's a tangent line, right? And that means that this little point right here is the point of tangency. Right? I'm not going to write it out, but that's the point of tangency. A common tangent means that it is a tangent line that touches more than one circle, right? So again, if we were to think that it touches both of these circles in only one spot, obviously I am not drawing a perfectly straight line, right? That would be a common tangent because these two circles have in common that this line is a tangent. That is a common tangent. And then what was the last one? A secant. A secant goes through two places in a circle. Remember, it cannot pass through the center or else that would make it a diameter, but then it just keeps going, right? So that would be a secant, right? And we can see a difference between secant and chord because a chord stops, secant keeps going. Those are all of our vocab words for circles. Okay, so some examples. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. Okay, segment, AC. Notice, right? Segment, ray, and line. You have to shout out to chapter 1. You have to keep in mind all of these things as well. Right, so segment, AC, right? That means it stops. So A is there, C goes there, right? Endpoints are on the edge, and in the center, that would be a radius. Don't forget the S. Ray, DE, let's take a look. DE goes from here to here, and it's a ray. It continues, right? That would be considered a tangent, right? And it is a tangent because it touches the circle in just one spot, right? Segment AB, right? Segment AB is from here to here, right? It goes through the center, right? And it touches both sides of the circle, so that would be a diameter. Line AE, let's see what other colors, turquoise, right? Line AE, remember line means that the arrows keep going, right? So it keeps going all the way through A to E and then keeps going on and on. So that would be considered a secant, right? Because a secant continues on forever. And then I put this in here myself. It should have a segment over the top. So segment AG is from here to here, right? Notice it stops. It does not continue through, so that would be considered a chord. Okay, chord, secant, diameter, tangent, radius. Okay, what is the diameter and radius of circle A? Right, that is a symbol for circle. Okay, so diameter has to go all the way through. Radius is only halfway. Okay, so we see that the diameter goes 1, 2, 3, 4, 5, 6 units, 6 units. And the radius in another color is only halfway. It would be 1, 2, 3, right? Notice 6 divided by 2 gives you 3. 3 times 2 gives you 6. Right, describe the intersection of circles A and B, right? Instead of saying describe, say how many intersections. We see that they just touch each other in one place, right? So just one intersection. And instead of describing the two common tangents, all right, let's just draw them, right, of circles A and circle C, right? Circle C is the green one. Okay, you can draw many common tangents here, right? You can draw a tangent this way, that's 1. You can draw a tangent line this way, that's 2, right? Obviously, I don't have a ruler, but I could draw one that touches both circles in just one place, 3, and I can draw a line that touches both circles in just 4, right? So we would have 4 common tangents between circles A and C, but that's not super important right now. All right, how many common tangents here, right? So same thing. If two circles are ever completely separate, right, just like in that example that we just did, again, I don't have completely straight lines, but there's 1, there's 2, there is 3, and there is 4. If the circles are touching in just one place, then we can only have 3 common tangents, 1, 2, and then just that one right down the middle, that's 3. Right? And if they're intersecting like that, then you can only have 2 common tangents in this example. So you can only have 1 and only have 2 common tangents there. Okay, central angles and arcs, right? A central angle is the angle whose vertex is the center. So example, right, if you want to add this onto your notes, the example here would be angle BOC, right? BOC, that is a central angle. The vertex is the center of the angle, or sorry, the center of the circle. A minor arc is an arc on the outside of the circle measuring less than 180 degrees. It will be noted with 2 letters. The symbol for arc is an arc, fun facts, right? And an example of that would be arc BC, right? So go ahead and add that onto your notes as well, right? A major arc is an arc on the outside of the circle measuring more than 180 degrees, and it will be noted with 3 letters, right? So 3 letters. So if we use another color, let's go with turquoise here. If it went from B all the way, sorry. That's a bad example. I want to erase that line. If I went the other direction and went from B all the way around to point D here, right? Let's just say, I think it got cut off, but I think this point is supposed to be labeled as A, right? Your major arc is more than 180 degrees because it's more than half of the circle. And you're gonna name that with 3 letters, right? You would name it arc BAD. And the reason why you label it with 3 letters instead of 2, because the end of this arc is technically B and D. If you just said arc BD, you could mean this arc that we drew, but you could also technically mean from this point B to this point D, right? And that's why I stopped in the beginning, because I was like, wait a minute, I'm doing a bad job. That's why you have to use 3 letters, right? Because if you just put BD, it could be this dark blue or this turquoise blue. But that's if you say BAD, you know it has to go through B and A and D. Okay, a semicircle is an endpoint, is an arc with endpoints on a diameter, and it will always measure 180 degrees, right? That example would be arc AC. Right, and that one, it doesn't matter if you have 3 letters or not, because going from A to C this way or A to C that way, it's still it is still a 180 degrees. Okay, so more vocab, right? Find the arc measure. Okay, remember we said that all circles measure 180 degrees. We said that semicircles measure 180. So that's enough information to figure out, right? If this is 110, right? Line segment TR is a diameter, which means that this half is a semicircle. So we automatically know that this part is 180, right? Which means we also know that from T to R is also 180. So to find this little missing piece, we can simply just do 180 minus 110, right? Which would give you 70. So you now know all of these different little pieces here, right? So arc RS, that's given to you. That one's nice and easy. That's 110 degrees. Arc RTS, right? So notice T is in the middle, so that means we have to go this way. RTS, so that's 180 plus 70. 180 plus 70 would give us 250 degrees. And then arc RST, if I use a different color, right now that's from here, RST, that is a semicircle, so we know that that's 180 degrees. Okay, same thing, measuring arcs, AC and BE are diameters of circle F, right? Determine whether the arc is a minor arc, major arc, or semicircle, then find the measure of the arc, right? So first up is arc BC. I am not going to do all of these, right? We're just going to do a few. Arc BC, right? That is already given to us. That's 70 degrees. Also, we know that that's a minor arc because it's less than 180. So it would be 70, and we'd call it a minor arc. Right, segment DB. All right, let's see where segment, or sorry, not segment, arc. Arc DB is here to here. Right, that means we have to figure out this piece here. Notice there's a ton of different ways we can figure this out. Right, it said that BE, this here is a diameter, right, which means that cuts the circle in half. That means everything over here is 180, everything over here is 180. So that means that 45 plus 70 plus our unknown question mark or X has to equal 180, right? So that means we can just subtract 45 minus 70 from 180. So if you just do that in a calculator, 180 minus 45 minus 70, what's left over is 65. So that means this one here is 65. But remember, arc DB is this one plus this one. So 70 plus 65 plus, that gives you 135 degrees. Right, and once again, that is less than 180, so we would call that a minor arc, right? If I'm going to use a different color now again. Arc AD, let's see, arc AD, all right? Here, we know that this is 45, but we don't know what this is, okay? This is also where Chapter 1 still comes in handy. Ladies and gentlemen, this line EB and AC, those are straight lines because they're diameters, right? So you can know that this half is 180, and you can also do 180 minus 65 minus 45, and that would give you that part. But also notice, right, this angle and this angle, they are vertical angles. That's still shout out to chapter 1. So that makes it even easier. If this one's 70, that means this one also has to be 70, right? That one means that one also has to be 70 degrees. All right, and now we find arc AD. 70 plus 45 would give you 115. Once again, that's less than 180, so that is still a minor arc. Okay, and if you don't believe me that this is 70, if this creates a semicircle, that means 65 plus 45 plus 70 has to give you 180. And let's go ahead and do that. 65 plus 45. Sorry, calculator. 65 plus 45 gives you 110, plus 70 gives you 180, right? That's how you can prove it. Okay, next one, arc ACD, right? I am getting a little messy, but I'll try my best, right? Arc A to C to D. So notice we have to go this way. Arc ACD, that's 65 plus 70 plus, this is our last remaining unknown one, right? If we said that EB is a semicircle, or we said that AC is a semicircle, either way, you know that this part has to be 180 minus 70, and 180 minus 70 gives you 110. So that we know that that arc has to be 110. So ACD is 110 plus 70 plus 65, which would be 245 degrees. Which is obviously more than 180, so we would name that a major arc. Also, we know it's a major arc because it has 3 letters instead of 2. Okay, the next one, arc DC. That one we already found there. Let me try using a different color. DC, we see DC is 65 degrees. We already found that part, and that's a minor arc, right? AE, we already found that part. That's 70 degrees, and that's a minor arc. Arc ABC, let's use a different color. Let's go with like a yellowish. ABC, we know that that's a semicircle, so that's 180 degrees, all right? And we would call that a semicircle, all right? And I guess we are doing all of them. EAC is E to A to C all the way over, so that's 70 plus 110 plus 70. Right, with 70 plus 110 plus 70 gives you 250, and that would also be a major arc. Okay, so that's how you find measures of arc lengths. That's all I have for today. Have a great day. Go Mustangs.